What's going on, guys? Chris here. So my saga with the workshop upgrades and improvements continues. So I was on the hunt for a drawer to keep all my bolts because I had like stashes of bolts. I mean, they were organized by size and all that. I had like a drawer in the drawers over by my on the other side of my CNC machine where the lathe is. I had a drawer over there. I had a drawer over here, like all over the place with bolts. So I got this bench on sale. I actually bought a cheaper one that kind of sucked from Amazon, but I sent it back because it was so cheap. The drawers were like on plastic, plastic rollers. This is soft close and it's a lot bigger with the bench top for literally, I got the other one for $220 and this I got on sale for $300. It's a $500 bench. It's a Husky from Home Depot, but I put all my tap and dies in here and organized all that, and my thread gauges and the other thread gauges and all the tap and die handles, but all the bolts are now in one spot. All my number 8 hardware, all my flange bolts, everything's in one spot. So that's always convenient and makes life a lot easier knowing, like, all the bolts are there. I don't have to go looking in multiple places. And then I think I showed you guys already, I brought the thread tapping arm back here, and that little vise is kind of a piece of junk. I have to put I have 2 bigger vices down there. I'm going to move one over. And then what else? The mill. So I didn't show you guys any of the part where I did a one-shot oiling system that has an electric pump that you can set how often it oils. And then I put a bigger stepper motor, or not a bigger, a more powerful stepper motor, but more importantly, a more powerful stepper driver that has been a lot more resilient, because I thought the other one was good, but when I started doing it with material under it and I was facing something or whatever, it was choking. So I put a bigger driver. And while I was at that, I'll finish about the oiler first. So I did a manifold on the side here. There's a 12 hose manifold there, and that goes to this, which pumps it, and then it goes out to every oil spot on the whole mill. Even underneath here, I've fitted one underneath the housing for the motor that turns the x-axis. I drilled the hole and cut out a spot underneath it, so I got the hose to it and got a fitting under there. And on the front, these two, and I used all good metal fittings. Here, let me just lower this down. I used all good metal fittings, and this is 4mm like 3D printer hose. So you say I put one on the top here, if you can see it now, and then 2 on the front there. Every oiling hole I put them in. So, and then the 2 on the Z, and then the 2 on the handles. I put them everywhere. So, and now all I have to do, I put this switch. I haven't mounted the switch yet. It's mainly done, but all the plumbing's done and everything's being oiled by it. But I just have to organize it a little bit better. But flip that on and see it's oiling every single spot for 4 seconds. And then after 4 seconds, it shuts off. And then if it were to stay on, which I'm not going to leave it on, because it's actually, I have to drill a drain in the tray that's underneath it, because it's not, none of it leaks. I did like gasketed O-rings. I put O-rings on every seal, and then thread tape in every connection. And some of these I had to drill out and tap bigger than the brass, because the brass wouldn't take the threads, strong enough to really tighten it with an O-ring. So it doesn't leak at all. Nothing leaks. It's just like the slideways end up having extra oil in it, and it drips over the side. So when I'm pulling it forward, see, I see the oil coming forward with it right now, because it probably didn't need to be oiled just now. I just was showing you guys. But yeah, there's drips of oil coming down the front right now just from turning it forward. Yeah, there's quite a bit. So you guys can probably see it, I'm sure. And that's all puddling up in the front. So I'm going to put a drain in here with a little catch for metal, and let the slideway oil go into a drain. Kind of like, this is my cutting oil right here, my cutting oil hand pump. This is for like when you thread pipe and whatnot, and this just spits out threading oil, and it recycles it. It just pumps it right through there, and then catches all the crap that comes out of it, because, you know, threading oil is like, good threading oil is like 80 bucks a gallon. So, you know, I'd rather let it recycle, because I go through quite a bit of it. But yeah, the mill is basically done. Finally, the DRO's done. All the scales are done. If you guys can see the screen, yeah, you can. Oh, if I move my arm, you can. So yeah, there's X, and then this is Z. So I have this here. I have a bigger motor that I was going to try to use on Z, because I mean, that one's okay. Don't get me wrong, it's a hell of a lot better than hand cranking it. And I am going to put the hand crank back on. I put the motor up top. I did have it on the side. I moved it, but I have a bigger motor that has a gearbox, and this is the seal from the gearbox. I took it off so that I could see if I could make the mounting holes line up with this. And if I can, I'll just machine a cylindrical piece. This receives like a motor shaft almost. It's like I got to measure it. I don't know the exact diameter, but it looks about 14 millimeter with a keyway, and that's what goes in the shaft. So it takes like a shaft in the motor shaft, in the gearbox housing. So I could make a gearbox. I could mount the gearbox, and then I could make that motor shaft that goes into the housing to fit the thread on top of the bolt up there, and mount it right on top of that. And it would work perfectly, and that's a lot more powerful motor. But is it worth all the trouble? Probably not, because this moves up and down pretty good like it is. It's a hell of a lot better than cranking it, and I really don't need more than that. So I'm probably in overkill mode now. So I'm probably just gonna just let it be, because I also picked up a new project, of course, like I always do. So I've been doing a lot more on my CNC machine. As I told you guys, I've been doing a lot more machining stuff. And I decided to bring one of my workstation PCs back here. And this is a big one. This is it's a Hewlett Packard Z840. And it's not as beefy as the one I have in my small workshop. That one, because I do most of my computer stuff back there, or up there. That has a M6000 24 gigabyte graphics card and an M1000. This has an M4000 and an M1000. And this one has, I think it's like 256 gigabytes of RAM and 2 Xeon processors. So the other one has 2 Xeon processors and 380 gigabytes of RAM. 380, it might be 380 or 382, I don't remember exactly, but it's 380 something, or 380 at the very least. And this one's 256. So it's a pretty stout computer, to say the least. And it's got 4 hard drives. It's got they're about, I think they're 1 terabyte each. So the other one has this one doesn't have the newer style of solid state drives. It has the solid state drives that you plug in. The other one has 2 slots for the newer style, you know, the chip solid state drives, and I have both of those filled with a one terabyte, and then I have a 10 terabyte that I used to use for surveillance before I put a 20 terabyte in there, and for the cameras on my building, I've got a 20 terabyte for that, and now I use that. Those are all the fans kicking on for the memory. That whole fan system is like turbo fans. It's a pretty serious computer. If you guys ever seen a Z840, then you know this thing's like 60 pounds, the case. Anyways, I got the case open for the MR1, and I'm gonna upgrade one of 2 things. Well, I already ordered the stepper drivers, so I'm going to put, let me see if I can get an angle where you guys can see what's going on down here. It's tough. I'm gonna take that electronics enclosure out because they did not do a very organized job wiring it. You know, this is wired the same way it came. You see, like, wires all over the place. I mean, I wouldn't do it like that in the electronics cabinet. I mean, look at, I got wires coming out all behind the computer, but that's because I pulled it out to show you guys this and to get to it myself. But the drivers are tiny. They're very small. I'm surprised how small they are. I don't know if you guys can tell. There's one big one, and then the servo drive down there, but those other 3 are very small. So I'm going to replace all of those, even the bigger one. I'm going to replace all 4 with these. I'm going to put these DM860T. So I have 3 more of these on the way. They'll be here tomorrow, actually. So I'm going to, and then I've got my label printer back here and a bunch of heat shrink label. So I'm going to label all the wires properly, like it should be. I mean, they did label a lot of the wires, but they didn't label the individual wires that go into the drivers. And if I'm going to keep drivers like that, then I'm definitely going to want them to be labeled. So if I ever have to replace anything, I know where all the wires go. So I'm just going to print a bunch of A+ and B+, A-, B-, and you know, the step, direction, and pulse, positive and negative, excuse me. So I'm going to print all that stuff and put the new drivers. I also was considering putting servo motors on here, but they're the self-contained servo motors. I actually have an email out to ClearPath, so I'm going to touch base with them and see if theirs would somewhat easily work with this. If I did their power supply and their self-enclosed, you know, fully enclosed, self-contained servos, if I were to use those, would it be able to work with the same signals from this system? And if so, then I'll probably get a set of those, which I would need to get 4 of those, because there's 2 on the y-axis and then the x and z. So it's, I mean, talking, they're not too bad on price. They're a lot more expensive than the other ones that I used on the lead screw. The lead screw ones are like $140 or $130 for one of the bigger ones, which you only need the bigger one for, which I actually have another 2 more actually big ones already, but I would only need one of those 2. That's only for the X, because that has a bigger motor. Z has a smaller one, and then there's 2 smaller ones on the Y, which, I mean, there's 2 of them, that's all you really need. But yeah, I gotta get this thing back in there, and probably I'm gonna take this piece of plexiglass off. I put that there because the housing had leaked at one point, but I fixed all that. I sealed everything. So I'm going to take that off, and then that electronics enclosure is coming off, so I can take it apart and work on it and get everything wired. I'm going to put some, you know, cable raceways in there and organize everything properly, and put the new drives in for now. I mean, I already ordered them, and the drivers are, you know, these are only like $50 a piece. I don't know. I know that they offer better drivers. I don't know what drivers they are from Langmuir, but they do offer a driver upgrade kit that I looked at when I got it, or they did. I'm assuming they still do. I've had it for a while. I've had this for, I don't know, 2 years or more, I think. So I know that they did offer a beefier drive setup, but I don't know if, like, how much beefier. I don't know if they're comparable to the ones that I'm putting in, or if these are better. I don't know the specs on the drives that they had, but I know the specs on these, and these are some pretty serious drivers, you know, stepper drivers. But obviously, the more efficient and more effective way to go is going to be the servos, which is why I'm more focused on that. I did order the drivers because, I mean, it's $150 and it's Amazon Prime through my business account. I can send them back, no questions, if I don't end up using them, or if I don't end up even keeping them. I'll probably install them, because I'm sure I'll probably get those before I hear from anybody about the servos, and then I'll put them in. But I also, stepperonline, I reached out to them with an email today too. So whoever gets back to me, and if either sets of those will be compliant with the MR1 and the low voltage setup, and they'll respond and work with the signaling system because I don't want to change any further hardware than that. I want to leave it. Everything works, and it works well. I actually started doing some engraving with it, which I had never tried before, and I didn't even think to do. It came to my mind. I saw a video on somebody engraving with a CNC, and I always used the fiber laser to engrave things. You know, it engraves in metal. That's why I got a fiber laser. But I never thought to use the CNC to do it, and I already had 45-degree bits, so I tried it, and this is what I made yesterday. So just a you know, messing around just to make something to see if it worked, and then I chamfered the sides, which it did. I mean, it worked out really good. It came out, I think it came pretty good. It looks almost three-dimensional the way it's in the aluminum. So yeah, it works good for engraving for sure. But yeah, so I'm waiting to hear from the two servo companies, or you know, stepperonline and ClearPath. So this is the 140, or the 180 watt. This is the 180 watt one here. And actually, this is the one I have in the lathe for the lead screw, which this had more power, it kept up to a higher speed with the same amount of torque, and you know, while cutting up to a higher speed than a 12 Newton meter NEMA 34 that I had put on the lathe, doing the exact same thing in the exact same application with the exact same hardware driving it. I mean, you know, other than the actual driver, but the same logic, the same TI board, and the 12 Newton meter stepper motor. It was a closed loop stepper, and it gave out extraordinarily low compared to my presumptions based on the torque. And the torque is I mean, you see the torque numbers on servos, and it's so different than on steppers. It's so much lower. You expect them not to be as strong, but they hold that torque. They hold that torque like they hold that torque incredibly well, and for a ridiculous amount of you know, speed and everything else. And steppers just give out. They lose steps and they completely give out. So unfortunately, the stepper didn't make it for that project. Not really unfortunately, fortunately, because it turned out to be way better with the servo, which is why I'm assuming it would probably be better with the servos. And I know it would be as far as like sound, because steppers are loud when you demand a lot of them, especially the big ones, really. I mean, you think it's bigger, so it's not as much work for it to do, that you're asking it to do more work because it's a bigger motor, but they're loud, man. They get loud. And you know, servos are just totally quiet. I mean, this servo just doesn't make any noise. The one on the lathe, when I was trying it with that NEMA 34, was unbelievably loud. This is the gearbox motor that I was telling you about. I'm going to show it to you in just a second. I just got to get this closed up so the oil doesn't come out. This is actually a pretty good motor. It's a good gearbox, you know, oil contained gearbox. This has a seal on it. This part that I took off right here, because in order to mount it, I'd have to follow these mounting holes and then be dead centered with the shaft that goes in the middle. So I had to take it out, and I would have to really mock it up and take some precise measurements to get this to work. But the other motor's working well enough. I have to get this down a little bit. I got to get a mallet to tap it, but this is what it looks like. So that's got you see how it's got the hole with the keyway right there? It's like a motor shaft goes in there, which I figured I would just make the motor shaft, which is what I intended on doing if I used it. But that's where I'm at right now. The CNC machine, I'm looking forward to finding out if I'm going to do servos, or even trying it with the new drivers. I'm going to put the drivers in tomorrow, and then I'll probably make a video of it working with the new drivers, maybe of part of installing the drivers. It'll probably be a couple days, but you guys will see it in this video, so it won't make a difference. It'll be a couple days before I get it going, because I'm going to organize that whole cabinet. And if I do that for the if I do that for the drivers, and then I end up not using them because of the self-contained servos, I'm going to be kind of cranky about that, but it is what it is. So it's me being impatient and not waiting to hear back, unless I hear back from these companies relatively quick or get busy, whichever of the two happens. Which there's a nor'easter storm that might be coming. That would be more snow for me, and if that happens, then I won't be doing any of this. So we'll see how that goes. But I do have other stuff going on, even if it doesn't snow. So we'll see how I make out. But I will let you guys know, and I'll bring back another video so you guys can see what I end up doing with the CNC. But either way, I'm doing one or the other. I'm either putting the upgraded drivers in, and then the servo, the stepper, I'm sorry, the stepper motors, they don't seem to have any problem. I think with new drivers, they would have a lot of power. Stepper motors, there's not really a big quality difference between one and another, other than like NEMA 17s, the LDOs are in a class of their own. But I haven't seen much of a difference as far as stepper motors, that the closed loop stepper motors go. I mean, I've tried a bunch of different ones, and I haven't really seen a whole lot of difference in them. I mean, the drivers are what really makes the difference, so that's what I'm upgrading. And then if I think that it needs new stepper motors, I'll get them. But I'm hoping that it won't be stepper motors in it. I'm hoping that those servos, and even if it's these servos, I would have to make some kind of an enclosure, because you got the dip switches right here, and you got the wires coming out of the top, and this port that's open, that's for the tuning port. That's how you hook it up to a computer and you can tune it. So I definitely want that to be available, so I would have to have like a way to open it and then close it again. So I'd have to 3D print something or something like that and make it watertight for the flood coolant. So that would be another challenge with these. The clearpath are watertight. So, or you can definitely get them 100% watertight, but they're pretty watertight anyway. So basically the basic models would be okay in there. And I mean, that's definitely a leg up. Duke. No. Sorry, he's chewing on a wire. He knows he's not supposed to do that. Duke. It's my dog, Duke. Come up. You wanna say hi? Say hi. Say hi, Duke. Say hi. This is my dog, Duke. He's a good dog. You give Daddy a kiss? Give Daddy a kiss. Thank you. Thank you. You good boy. He's my good dog. So anyways, I will let you guys know how I make out. I'll let you guys see how I make out, and how the MR1 works with the new drives, and maybe even new servos. Maybe both. I might put the drives in and then get word back that the servos will work, and then put those in. And you know, like I said, I'll be a little cranky that I did all that work to undo it, but at least the wires will all be labeled and routed properly and clean in there. So anyways, that's that, and I will see you guys next time. Enjoy. What's going on, guys? So it's Chris, and I'm here showing you the MR1 upgrades, modifications, and whatnot, and my messed up process of I should be a little more thorough in making decisions before I tackle projects, but that's not what I have a tendency of doing, unfortunately. So I have upgraded all the drivers for these stepper motors in the MR1, and I upgraded the motors. Well, so I upgraded the 2Y motors. I have another motor that I ordered for the X and the Z, but the Z axis I assumed was a smaller one, which I do have, and it's not. It's a bigger one like the other one. And the bigger motor that I ordered for the X, that was for the X, and I need both the Z and the X to be that size. I ended up getting a closed loop, and these aren't closed loop, which I think it'll still work. Just the alarm function won't do anything. But I'm not going to change any more motors because I got all servos, and they do work. I tested it. So that's where, I mean, the motor thing was just a mishap with one motor, or well, turned out to be two motors, whatever. But this is like all of it has to get redone and differently. So all the drivers that I upgraded, I mean, I essentially just did all that work to show you guys, which, don't get me wrong, you know, I didn't do it for that, but but it's to your benefit, because you'll get to see in the end what a difference servos make. And the MR1, when it's in motion, I mean, it's a CNC machine. It's going to make noise. Obviously, it's cutting metal, it's cutting steel, cutting whatever it's cutting. But the motors are loud, and it's undeniable. I mean, they're loud. And this is quieter. This is with the new drivers. I mean, it moves with authority now. It really does. And I put a much bigger cable chain, because that cable chain that I had on here when I did the cable organization at first, it's actually right here, this little one right here. Hold on, I'm going to take this camera out so I can show you what I'm trying to show you. That's the one that I had in there before. That's a 30 millimeter. I ended up putting a 50 millimeter in, and that's much more rigid, and it's on the 2 pivot points that I put on before. That I had another video when I was doing that. And the cooling system, this is coming out. So what I'm putting in is I'm going to put one of these on each side, which I actually am not using this one right here. That's why it's not in yet. There's no mounting holes in this, and I could have drilled holes and tapped them through it and then just sealed the holes, but I didn't want to have to do that, so I ordered a couple new ones, and I'll just send these back. And I have 2 more of these coming, so I'm going to have 2 on each side of the spindle. So there'll be 4, 4 coolant spouts coming, 2 from each side. And I'll put one. I'll mount one here, and then I'll mount one here, and I'll have like a hose crossing over in the front, or preferably a threaded rod, but I don't know if I'm going to have the right size, and I only have, actually I do have a thread tap for a 1/4 inch NPT. They're national pipe thread you got to use for that type of stuff. But I know I have 1/4 inch to 1.5 for actual pipe threading for HVAC stuff, but anyways, I need a 1/4 inch for that, but I think I have a 1/4 inch die. Anyways, and then this I 3D printed the mount for the touch. This isn't the one that they sell. This is that one. Kind of the buttons like fell out of it. But anyways, so just a thing to note is that the couplings right here, the couplings that couple the motor to the ball screws, they are 6 millimeter. And so is the shaft on the motor, surprisingly. That's the first for me, is seeing NEMA 23 motors with a 6 millimeter shaft. I've seen them with 12 and with big shafts, and they're typically with 8, but I've never seen 6. So that's the smallest I've ever seen. I don't know if they did that to match the ball screw, but you just take the coupling, and if you have a lathe, I mean, you really need a lathe or a mill with a. If you're going to do it in the mill, the reason I didn't do it in the mill is because you really have to center that perfectly, and the lathe kind of just does that for you by being aligned already. The mill, you need something like this. It's like this is a center finder, so it's a good center finder, and then this goes in the mill, and then you put this, there's different tips that you can use, and you put that on whatever you're trying to find the center of, and hold the shaft. And it spins in the middle, and it's actually really precise. But if you're going to do it in a mill like this, you got to use a tool like that to make sure you're in the center, because it's really important to get it dead center. But it's obviously much easier just to put it in a lathe if you have one, or get new couplings. And if you need to get new couplings, you need couplings that go from 6 millimeter to 8 millimeter. So the shaft of the new motors will most likely be 8, or depending on what motors you get. The servos that I'm using are, well, I have 4 out of 4, but I have 3 out of 4 really servos that I'm going to be using, because like I said, I didn't realize that the Z was another bigger motor like this, which makes sense because the spindle head is heavy. So it makes sense to use a bigger motor there, but I hadn't paid enough attention, obviously. I just assumed it was a smaller one like these, and it's not. That also makes sense because the Y-axis has 2 of them. So these are going to go on the Y, the 2 of them, and then I'll send one back, and I already ordered another bigger one like this. So I have another bigger one like that, but it's a different manufacturer. It's the same thing as Easy Servo, but I just want to stick with the same manufacturer so I can use the same tuning software for all the motors and the same tuning cable and everything. I can just switch it from one motor to the next, because with servos you can actually tune them excuse me, you can actually tune them like right to the motor itself rather than through firmware or whatever. And then these are all the new drivers, which are all coming back out, so it's not really much point in showing you. But I mean, I did organize all these cables. I took a short video of when I first opened it up. It was kind of a mess. I mean, it's not as neat as it was right now, because I've had to change a bunch of things while I was connecting it, different direction and whatnot, having to switch wires around. but I had to remove a couple. There's a cable, why am I having such a brain fart? There's a raceway in the middle of the power supply and the drives. But those drives are all going to be gone. I'm not going to need any of those because these have the drives built right onto the motor. And that's the drive right there. That's the whole thing. It's the motor and the drive. So I'm going to have to also, I'm going to have this like this for a little bit. I'll probably complete it with the servos before I put this video out because I'd like to have you guys see it completely done. Or maybe if I get around to this video, I'll put this out and then I'll put that out after with it completed with the servos, because I'm going to have to design and probably 3D print, maybe in TPU or polypropylene, a 3D print a housing to go over that drive, because it's in this enclosure with the liquid coolant, and this has the dip switches on the back. It's not going to work like that. It's definitely got to be sealed. That housing has to have something over it. So I mean that drive has to have a housing over it. So I'd like to make something that will like slide right over this, and I'm not really sure how I'm gonna do it yet, because with the ports right there, I mean I could position it where over there I might be able to position it with the wires going down. I don't know if let me see, let me just mock it up. Oh, this is actually bigger than that. Yeah, it's a good amount bigger, so it might actually, yeah, that will work. Okay, because of how much bigger the motor is, you see the size difference? That's the encoder and the driver, but it's still substantially further out. So that's why I could never, I would have used the bigger, I'm leaning on the freaking control. I would have used these bigger ones on every one if I could have, but there's not enough room in the back on the Y. If you guys don't have one of these machines, you see, there's just not enough room. I mean, it's hard to even get the bolts to mount the mounting holes. And these even the smaller ones are going to be bigger than what's there, just like that one. These are going to be, well, actually, the ones that I put in now are bigger than what I took out. Those are slightly bigger than these. I mean, like 10 millimeters or maybe 15 millimeters or something. But anyways, I'm looking forward to seeing how these work. I was thoroughly impressed with that same exact servo right here when I did this on my lathe. I did the electronic lead screw, and I did do it with a NEMA 34. 12 Newton meter stepper motor, and I had the motor mounted to the side of the lathe, and with a high torque drive belt driving the lead screw, and it didn't have even near the amount of power as this. Like, it had a good amount of power. As soon as you get any kind of motion, like not even like a dramatic amount of motion, like a small amount of motion, it was really not, it shouldn't have been quitting so easily. It quit at like 300 to 500 RPM for a 12 Newton meter, 1600 inch-pound of torque, NEMA 34 stepper motor. And this thing will go over 1,000 RPM. I mean, 1,000 RPM on that, not on this right here, not on this. This is going like 3,000 RPM or more. But this can actually really keep up and have a load on it. I mean, I did cut steel with it. I don't think I cut it at a crazy high speed, but I cut aluminum on it pretty darn fast, and it didn't even hesitate. I mean, I've yet to get the thing to quit, except when I was testing it, and that was, kind of deliberately. I wanted to see where it would quit, but it surprised me for sure. So that I've been thoroughly impressed with that, and honestly, even before that, with servo motors versus stepper motors, because this thread tapping arm over here, this is an AC servo. It's a 220 volt NEMA 23, and that thing has got incredible torque. Like it's unreal how much power this thing has. It doesn't go too fast. It's not. I mean, it will go faster if it was hooked up to or programmed different rather on the drive. But the way they have it programmed, it's low speed, high torque, which is what it needs for that application. Plus, that's what I'm using it for. So I'm not going to try to change it. But that motor has got so much torque, it's very surprising. So I have a couple of AC servo motors that I'm not sure what I'm going to do with, but I started thoroughly exploring them and learning how to program them because of that motor. Because when I got that, I started learning about servos versus steppers and was thoroughly impressed with them. So just something to keep in mind, that they're pretty serious. And they're totally whisper quiet. Like the way that this makes all that motion noise, it's not going to make any motion noise. I mean, you'll hear the lead screws, the ball screws. That's it. You won't hear the hold on. You won't hear that ring. You won't hear that anymore. I could show you, but on my if on the lathe, but when I turn the variable frequency drive on to get the spindle turning, to get it to move, because it goes by an encoder, it'll make noise. The VFD will you won't notice the difference because the variable frequency drive will be louder than it would have been. But anyways, so that's what happened, and that's how it's gone so far. It's been frustrating, and it's been very frustrating knowing I'm doing this to undo it and redo it, but I can't redo it yet, and I'm probably going to want the machine operational in the meantime. So I mean, I had to finish what I started at least. I mean, I had already ordered all the drives and the motors and also the servos, because I didn't know which was going to work, and I figured, I'll just not use and return what I do use. And now I'm going to end up having extra motors because I did put them in. The drives, I could probably return the drives. There's nothing wrong with them. But the motors were in the machine. I can't really return those. But anyways, so yeah, I'll take a little bit of a loss there. But plus I had to order more cable because instead of routing separate power cables to every motor, because it needs 6 wires now instead of 4, because the power goes directly to the drive, which is on the motor. So I'm going to that's a 36 volt power supply that comes in here in the electronics enclosure. I'm probably going to remove that completely, get a small DIN rail 36 volt, because I talked to Jake over at Langmeyer Systems, and he said that the control board does want that whole 36 volts. So it doesn't need very much amperage though. So a small DIN rail mount 36 volt would do fine. And I'll probably put a heavier duty 48 volt for those are DC steppers or DC servos. So AC servos would be seriously badass if they were on all the axes of this. But I'm not gonna go that crazy. Because the servos are like, that spindle servo is probably $400, maybe $400 or $500 at least. So they're expensive. I mean, that's a much bigger motor, but even the NEMA 23s or 24s would probably be, $200-300 each. Which, I mean, these weren't cheap. They're 130, I think it was 130 for the bigger ones. So that's 260. I mean, it's honestly, the clearpath motors, I would have spent that on one motor, that price of 2. So it would have been double the price, more than double, because the smaller ones are like $90, $100 out the door. I think it's like 106 or something with tax. 10, I don't remember exactly, somewhere around there. But yeah, the clearpath motors are substantially more expensive, but they're also substantially more dependable and reliable, and they're already water resistant. So that's got me really kind of considering switching it again. But anyways, that's oftentimes in the past how my projects have gone. I'm indecisive. I'm decisive, like I'm ordering this, I want to try this, but I'm decisive in too many directions. That's a more accurate analogy. I don't know which way I want to do it, but I want to do it all the ways to figure it out. So it gets expensive and frustrating. So anyways, I've still kept doing these projects, so it hasn't really stopped me. But hopefully my trial and error will benefit you. That's the hope. So that's that. I'm definitely going to machine some stuff with it while it's like this before I put the servos on it. In fact, I'm going to cut a part, and I'm going to cut the exact same part with the servos when I'm done. I'm going to design something. I don't know what. I'm going to think of something. I'm going to design something once I finish with the cooling system and whatnot, because I'm going to leave these drives in here for now. I'm going to close up the enclosure, and that's going to be that for the time being. And I'm going to, I just have a little bit of cables to clean up, and I have to clean out the enclosure. But once I'm done with that, I'm going to figure out how I'm going to waterproof those, or if I'm going to get clearpaths and just say fuck it. Excuse my language, but I don't know which route I'm going to take just yet. So for the time being, these are going to sit right, well, not there, because if I have to weld something, I'm going to need that. They're going to sit up there on top of this ultrasonic cleaner that I hardly use. And these motors can go there. So I'm going to try to figure out how to enclose those drivers on the easy servos, and honestly, decide if I'm going to go the other route, which I'll probably figure out a way to make those work. They're already here. And the other steppers I'm not even going to open. I'll just send them back because I'm not going to use it. And that one's doing fine for what it is. I didn't machine out that obviously that coupling yet because I haven't changed the motor. But I mean, these just the drivers. That's the most important part. That's the most benefit you're going to see is the drivers, because I mean, even just when I did the, what is it saying? Just when I did the drivers before I did the motors, the drivers made the biggest difference by far, and probably are going to make the biggest difference overall, I would assume. So, I mean, so far by what I've done, I mean, the motors probably are making a difference. I haven't cut with it yet. That's where it's going to really show if it's the drive if it's either the driver or the motor itself. But the new motors are pretty high torque motors. They're like 6 amp. They're small, but they're high torque. I don't remember how many newton meters of torque they were, but I know that the servos are rated at a lower torque. If you look at the torque spec, you'll see that it's lower, but it holds that torque all the way through 3,000 RPM. So when these things are moving, if you're cutting at 100 inches per minute, that torque is not there. I mean, it's there, but only to a certain point. And also, they don't have any way to stop or to try to catch up if they get behind, or they don't even know if they're behind. So they're just assuming they're in the right place. So if it screws up, it's just going to keep screwing up, and screw up even worse. So there's a lot of other benefit. Closed loop steppers will give you that benefit as well, but they don't give you the sound benefit. They don't give you the power benefit at high speed. And when you get up to high speed, there's nothing you can change about a stepper motor losing steps. It's just going to do it. Even if it stops, it's not going to try to catch up, and it's not going to not stop. So those are the benefits of servos that you can't replace in my experience so far. So I'm eager to see those benefits in this machine. But in the meantime, I'm going to, other than those couple of things to finish this, I'm going to design a part and cut it. And I'm going to keep that same part and design, and I'm going to cut it again when I do the servos, when I put those in. So we'll see how that goes. We'll see how they look next to each other. And I'm going to make sure it's a high precision part, like with some intricate, maybe the square rectangles, circle, square, rectangle, whatever it was that they had on when the videos when you're assembling this machine. Circle something square. I don't remember what. Circle diamond square maybe. I can't remember. But anyways, it was a very precise measurement. Oh, and I got some new Mitutoyo micrometers. So that'll be fun to use those on. Anyways, I will see you guys whenever I get to complete the multiple things that I have to finish on this. I have another wedding coming up. I feel like I've been to so many damn weddings. Anyways, I have another wedding coming up this weekend, so I won't get anything done this weekend. But hopefully I can get this out to you soon, because I know this machine has gotten pretty popular and more people have them. And I've been finding a lot more online about it too. When I've been keeping an eye on it, see if anybody comes out with some cool new stuff. There's some people that have gone way further than me, modifying. I don't know about the motion system. I didn't see anybody go into detail about the motion system. Only a couple of small things, like people upgraded the drivers or whatever. But I didn't see any servos. I didn't see any stuff like this. But I saw a couple people did like self-tool changing spindles. And I thought about putting a water-cooled 24,000 RPM spindle on it. But I like the big servo that's on there. And really, I don't think it needs to go faster than 8,000, because it cuts everything I throw at it. I mean, I've cut some pretty hard steel with that thing. And the alarm goes off when it's overpowered, when it's over torqued, whatever, and it just stops. So I mean, I think it's gonna be a resilient motor, and I don't really want to change it because of that. But anyways, I'll let you guys know how I end up what I end up deciding on all the rest of it. But for now, the stepper motors, I mean the spindle motor is gonna stay, and the motion system is in the works. But it's been upgraded already, so we'll see how it does. But I'll update you on the next video, on the next segment of this video. All right, have a good night, guys. Later. Hey guys, Chris here. Sorry, I'm kind of frustrated because I just recorded this and my microphone was not on because I don't know. It was asking me if I wanted to mute it or something, whatever. Anyways, I'm back in my workshop. I got back from the wedding and decided to dig into this because my other half stayed back with her siblings for she's staying until tomorrow. So I decided to dive back into this, and instead of replacing that X motor with the bigger stepper motor that I had gotten, which I did get the closed loop by accident, but it still works. You don't have to use the encoder, but I'm not going to use the motor at all. Instead of doing that, I wanted to just use the servo, because I did do some testing. I saw before I did the lead screw on my lathe, I saw James from Cloud 42 doing the testing that he did, and I decided I was going to do some. I didn't do very scientific testing, but I did do some testing. I used a 17-pound motor and a GT2 belt pulley and a GT2 belt, a Gates high-temperature belt EPDM that I had left over from one of my 3D printer builds, and I fastened that to the motor, and I was holding one end while it was pulling up, and I would just kind of pull up the slack as it pulled it up, and the servos did it no problem. And when the motor got up to the ledge of where the vise was mounted that was holding the motor mount, and the motor hit the ledge, the servo would fight it, and it was like you could see it going back and forth, like it wouldn't let it go, and it kept trying. It's fighting it literally. The steppers, the steppers had a ton of torque. They surprised me that like they both had a ton of torque. They both lifted it no problem. But the steppers, when they got up to that point, they would pull, and then once it stopped, they would just give up and it would fall. And that's it. They just, once they lose steps, it's over. And then whatever you're working on, it's done. It's getting all messed up. That's why it was good for the lead screw. That's why it's good for this, for the servos, because that's not going to happen. So anyways, I just figured I'd let you guys know that. I'm going to show you again, because you're not going to hear anything in the other one because there's no audio. But also, this is a pretty profound difference that between the steppers and servo, and I have some of both in there right now. So I wanted you guys to be able to hear the difference in contrast right back to back. Also, this is the water cooling system that I put in. I mean, not the water cooling was already here, the flood cooling. I just changed all that one flexible nozzle to 4 fixed nozzles. I'll turn it on for you when I'm done with this and I make the next segment, but I don't want to get everything wet before I got to get in there and put the motors in. But the 4 jets all hit right on the bit, and they don't move, so it's no flexing around. And then I put a valve here so you can turn them on halfway, you can turn them on, turn them off. And then I did a bigger cable chain to keep the wires from, you know, the other cable chain, like the bottom pieces that snap in, were popping out, because that was a 30 millimeter. This is obviously like a 60 millimeter by 20 deep. This one was 10 deep by 30 wide, so that might even be more than 30 in comparison. That's what I took out. Oh no, it's about double. Yeah, it's probably 60 by 20. Yeah, double the depth too. The depth is really what I needed, but the width helped. And this one is very rigid, and it does hold up to it moving around, no problem. And nothing snaps. I don't have any zip ties holding the cables. I'm gonna zip tie the ones in the back, but when I'm done. But anyways, so listen to this. This is Y, with the 2 newer steppers and newer drivers. Now this is X. No sound. That's all you hear, dude. It's crazy. When you stop, you can hear a little bit. That's it holding its position right at the end, but that's all you hear. That's the most you're gonna hear. See right there? Right. I don't know if you can hear it. That little bit of feedback. It's nothing dramatic. It's very subtle. And then I still have to tune these on here. I did change some parameters before I put that one and the other 3 I'm going to put before I put them in. But I didn't change all of the parameters by any stretch. There's plenty more I'm going to be changing. So I'm going to just get this in position. So I'm going to do the 2 Ys, because they're going to be the harder ones for me to get to. And I'm going to get those over with, and then do the Z, and then I'm going to seal it all up so no water gets in, and then I'll bring you guys back. And I'll do another segment, hopefully today, maybe tomorrow. I should be able to get to it this morning. But I'll bring you guys back and let you see how it goes. I'm excited to show you, and I'm excited to see it myself, frankly, because I've been eager to put these servos in since I got them, and I wasn't going to put another stepper motor in while I have all the right motors. And you know, I said, you know what, I'm going to try the one motor, and if it works, I'm going to just do them all. And it worked. I mean, as you see, yeah, it's pretty unbelievably quiet, and just as much torque. I mean, it's moving just as fast, same weight head, and you know, I haven't cut with it, but I'm going to try them all, and if worst comes to worst, I'll switch them back if I needed to, but I highly doubt that's going to happen with the experience I've had with these so far. But anyways, that's that. So I will see you guys in a little while, and I'll show you the water cooling. That I did all hard pipe, which has given it a tremendous amount more flow. The amount of water that I got from the flood cooling system was so tremendously lower than it is now. Even when that one jet was on full blast, it didn't come close to what all 4 of those do. And always, by the time you're machining something and it's moving around, the thing would always move around. It's not fixed. So all I have holding that whole thing around the whole spindle head, holding it up, is that one thing that was holding it up to begin with, that comes with the machine. But it's just going into a valve to all hard pipe, like the 2 manifolds. And then I made a bunch of quarter inch NPT, National Pipe Thread, 1/4 inch fittings that I machined down a piece of bar stock aluminum, and I threaded it for 1/4 inch NPT. And I don't know what the thread count is off the top of my head on NPT, but it's 1/4 inch NPT, National Pipe Thread, and that's what you need for these manifolds that I got. Then pretty much all the manifolds are going to be National Pipe Thread. It's just what size. But these are 1/4 inch, and they're the same thing as pneumatic fittings, air compressor fittings for whatever pneumatic tools you guys use. So yeah, I made those for a bunch of plugs. There was like 5 holes in each one, and I only needed 2 on each side for the 2 jets, and then, you know, the one in the middle, and then the one on the end of each, because I ended up coming down from the top into it, and then in the top on the other side. So I needed several of them, like 6. But anyways, it all worked out. That's working great. The cooling's working great. I'm eager to get the rest of this done, and then this project will be. I'm going to leave this machining. I'm not gonna change anything else once the servos are done, unless I have to revert back to the steppers, because the new ones do work really good. But I love that being so quiet. You're gonna hear metal being cut, but like you can't get rid of that. But that's such a smooth sounding motor. I'm very happy with it. So anyways, hopefully you guys will see me with all the servos happy as a pig in shit very shortly. All right, I'll see you later. Hey, what's going on, guys? So I just wanted to show you how I ended up with the MR1. And before I'm just about to close up the electronics enclosure, I made a decision on what to do with what axis and what motor, and I ended up doing 3 of the easy servos on the X and Y axis. The Z, I went with a closed loop stepper, because the Z axis has the weight of the head pulling down on it. So with that weight, it was making the servo motor kind of whine holding it up, even the bigger one, because if you guys know anything about stepper motors, they have a permanent magnet in them, and that's what creates the steps, is the magnetic field moving. So with a servo motor, it's set up very different, so it doesn't have that. It had the power to hold it up. I mean, honestly, it doesn't really move very easily, even without a motor on it. You can push it up and down, but it's got to turn that ball screw, so it's not like it's movable, but it's definitely feeling the force of it, obviously, on the servo. But it was making that whine, and I probably could have tuned it out, but I decided to go with the closed loop stepper on just the Z axis, because the main thing about the steppers that I wanted to convert it to servos is the steps during, like, especially round movements. You'll see like a step, it'll be like like a little bit curved, and then a jump, and it's subtle, but you can notice it. With servos, that won't happen, and these have enough power. It moves very smoothly and very quickly. It moves, probably I can if I put a Mach 3 board, which I have a Mach 3 board that I'm considering trying to that with at some point, but right now I have everything done really well, and it's working good. I just took it out to clean it up and to secure everything inside the enclosure. So I took out the 36 volt power supply. I put a 20 amp 48 volt large 1500 watt power supply in it, and I put a buck converter for the 36 volts going to the control board. And then the 220 servo is obviously still the same way. And then I did the one stepper driver for the, it's a big driver. It's an 860, a DS 860. So I got the one stepper driver for the closed loop stepper in there, and that's that. So I'll show you the enclosure before I close it up and get it going. And the cooling system's all done. That worked out great. This is the enclosure. This is how I ended up with it. So you guys, I don't know if you saw, I took a couple of clips with my cell phone because I didn't have the camera set up, and I didn't want to set it up. But I didn't want to stop what I was doing to set it up, is really what it was. But I took all the wires from the control board. I had to cut and splice a bunch of them. I just soldered them back together and extended them so that I could run them through the channels and make it all nice and neat. But this was kind of a rat's nest in here before, so I cleaned all that up, put the bigger power supply going vertical because I only need one driver now. Then that's the buck converter, the control board, and then the 220 servo drive, and then all the outputs. And then I added this output right here, which this goes into another one of those the same type of connectors. Those are the aviation connectors. I did another one of those for the power to the servos, because it runs straight up to the servos. And then I ran a 4-wire 16 gauge because I'm using 48 volts on those. I used a 16 gauge 4-wire CNC wire, so it's pretty flexible. And then I ran that up, and then I split it off into the 3 motors, which was 4, but then I got rid of the last servo, and I just abandoned that last one. So I'm going to, right now, I didn't design anything to cover these. So what I'm going to do is I'm going to wrap them in some 6 mil black plastic that I have for when I do lead jobs. I'm going to use that really good electrical tape, that the electrician's tape that it sticks to itself. So I'm gonna secure it to the motor around the driver over the dip switches with that tape, and then I'm going to brain fart. I'm going to wrap that. After that's secured around the driver, I'm going to wrap that up around the wires and then seal the seam, and that'll keep it watertight in there, and I'm not going to have to worry about it. And then I can just pull that open when I need to get to the programming port. But right now I'm not doing anything that needs water cooling, so I'm not gonna wrap them just yet because I want to tune them first. I want to finish tuning them. I did tune them a little bit. I changed a couple parameters, but I want to finish tuning them before I do that. So right now I'm just gonna put the cover on the electronics enclosure. And I haven't decided if I'm going to hang this back off the back leg like it was or not yet. But I did thread these. I rethreaded all the holes in it because they had like self-tapper screws in there, and I rethreaded them M4, and I got a bunch of M4 button head screws that I'm going to use because it's just nicer and neater and better that way. I meant to bring that electric screwdriver I had with the 2.5 millimeter, but that's all right. I'll just use this. So these are M4 button heads, so they have a 2.5 millimeter head on them. So that's what I tapped all these out to be. So I'm going to close this up with black M4 button heads, and that should be that. And I got I drilled and tapped. Basically, they had the drivers secured with you had to put a nut on the back, and I didn't really care for that, so I threaded them. I threaded the holes. I did M3 on that, and this way when I put the driver in, I only had to do it for one driver because I only used the one driver. All those servos have drivers right on them, so I did that just for the one driver on the two sides to hold that in place, and then I did the same thing for the wire channels, the raceways. I did that for the power supply. I just drilled and tapped the holes for pretty much everything, that even the buck converter. I did it on standoffs. But I did everything, and I put new standoffs. Even their control board was like that. It had, the same thing. It had like plastic spacers behind it as standoffs. So I drilled and tapped out M3, and I put M3 standoffs that take M3s in the front, and then I screwed those into the enclosure, and then I screwed the board in from the front, and that's that. So everything is threaded in now, where you don't have to use nuts on the other side. So now all that's left to do is put a couple screws up here, and then I got to decide if I'm going to mount this back on that leg. This thing went right here, like this one. I don't know which one it is that I didn't use. There was 3 of these on the back that have screws on them, and then the nuts go on the other side of the leg when you put it through, which I probably should put it there because I'd like to have it off the ground. So I probably will put it there. I just need to put it up there and see if that's what I'm going to do. But I've already tested it with this setup. I tested it with all steppers. I tested it with all servos. And this is where I landed with the one servo not being in there and having a stepper there instead for the Z-axis because of the weight being held. And it didn't let it move. I just didn't like the whining, and I could have tuned it out. I didn't feel like spending the time it would have taken to tune it out, because I already have to tune these as it is to get to the best parameters they can the best way they can function with the axis that they're moving. But right now, the last thing I did with this, which is what I'm going to show you guys when I test it, I'm going to show you on camera, let it run an operation that I already had. The last one I sent to this was, I was just testing with engraving because I never did use this for engraving. I have a laser, a fiber laser, and I usually engrave with that. But since I have the CNC machine and I was thinking about it, I was like, you know what, I probably should give it a shot to engrave with that. And I used, I have a 45 degree chamfering bit on it right now. This is a 1/2-inch bit, or is that a 3/8 bit, or it's a 3/8 or a 1/2-inch chamfer bit. But it just goes barely down into it, and it engraves it. And I engraved on one of these pieces of aluminum. This is 2 by 4 by 1 inch thick, 2 inches this way, 4 inches this way, piece of aluminum bar stock, and I engraved into it to fill in the whole space. It says "Real men run CNC machines." So it filled in the whole block, and it came out really good. And I chamfered the whole outside perimeter. So I'm going to run that program and let you guys see it engrave that, because I already have the program in here, in the computer rather. So I can just send it real quick and let you guys see it. The nuts for these should be around here somewhere. I have no idea what I did with them. Let me see what thread it is, and then that's all my wires. These should actually have a lot of slack that I can pull out. No, maybe not. Or they do, and I just didn't pull it down, so I can't get it out right now. But it doesn't matter. I have enough for them to all connect where I had it, and that'll keep it off the ground, which is good enough for me. All right, I'm gonna have to move the computer and then mount that because I'm done with it. I'm not gonna change anything else. So I'm gonna do that. I'm gonna pause the video. I'm gonna find the nuts and get that mounted on the leg, and then I will get a new battery for the camera. And once I get it mounted and everything connected, I'll bring you guys back and I'll let you hear it, because I did take a short video with my phone because I was so excited once I finally got the servos wired and in there. I was like, holy shit, this is so quiet. You can't even, it's like all you hear is the ball screw. I didn't even think it was working, and it was moving, and then I saw it and I'm like, oh man, it's working. That's that quiet. It's incredibly quiet. You're gonna see in just a moment. I'll see you guys in a few. Okay guys, I'm back. So here is the electronics enclosure. It's kind of behind the computer. It's where it used to be, mounted to the leg, which is why that stop doesn't make any sense, but I put switches in the front, so I have to stop right there. And then I am just tuning the motors. I'm not gonna keep doing this, but I'll just show you briefly one test that I've been running. So I have it where it's set to go. This is just an oscilloscope that's seeing what is, let me grab the controller. It just shows you different parameters while it's moving, and then the other screen is a test screen, and it's showing what it's calling for, and then you can set it to call for different things. Oh, I don't think I can move it while it's in this. Yeah, no, while it's in test mode, I can't move it. So I'll show you. I have it set to move 100 millimeters, and back and forth, and it's going to do it 25 times. And the acceleration and deceleration time is 100. I'm going to set it to 50, and interval time is 200 milliseconds. Velocity is 800. I'll do it at 1,000. Okay, I have to stop the last test. Positive and negative running mode. Okay, so I'll start this test, and then I'll switch over to this screen so I can see the whole oscilloscope. I'll bring this over here so you can probably see them both at the same time. So that's the graph of what it looks like on the oscilloscope while it's doing this. So I think it pretty much goes without saying these servos are handling this no problem. I mean, the fact that NEMA 23 steppers that were equivalent in size were handling it no problem pretty much tells you that these are gonna handle it with no problem when I've seen what these are capable of. And in fact, I tested these in different, like I actually looked into and considered buying an actual torque testing device for for motors and for stuff like this. And I did consider getting one. I just didn't go through with it because they're pretty expensive. I mean, they're like $1,000–$1,500. The cheapest one that was any good was $500. With like $600 probably by the time you pay tax and everything. So I didn't order one because I don't honestly, I don't know what stopped me, because that's usually something I'm weak at and I usually just order it. But I didn't, so I stopped myself somehow. I'm gonna disconnect. Okay, disconnect, bye-bye. Yes, we're done. Okay, I'll leave this open so I can use it next time. I'm gonna come back and do the other motors before I waterproof them. I'm gonna wrap them up after I'm gonna finish this stuff up, but I wanted to show you guys this thing actually doing an engraving. It's not gonna be like, it's gonna be cutting, but not like, you know, superficial cutting. It's gonna be engraving. So there's a 45-degree, I don't remember if this is 1/2 inch or 3/8. No, that's a 1/2 inch bit. Let me see which one I took out. Yeah, it's definitely a 1/2 inch bit. So it looks just like this. This is the bit that's in there, but this is the same one, only 60-degree. That one in there is a 45. So that's what the bit looks like. It's a chamfer bit, but these are what you use for engraving. I mean, you can use, I have different kinds of bits too. I actually have one of the spring-loaded ones. I didn't really try that one thoroughly. I might try it again. The spring-loaded bit. It's very small. It's let's see. Yeah, it's pretty small at the tip. This is the spring-loaded one that I got. So this actually is spring-loaded, and there's not really enough tension on it. Honestly, I don't use the tool setter unless there's multiple tools needed during the process during the course of a workpiece. And this I already ran, so it knows where the work is, and it's in the same spot that it was before. So it should go right there. But let me just zero it. So I'm going to check on the work parameters, the work location. Okay, so it's not actually zeroed, so we need to home it. Okay, let's see how quiet it is. It's crazy. You don't hear anything. It's nuts. It was never that quiet. Okay, so now we're at 0 on the machine, and now we got to bring it to the work. And then I'll zero everything out when I get over there. And I'm just gonna start up the spindle and touch off on it, and then I'll zero out the work, and then I'll start to run the program. I have to upload it real quick. I mean, just upload. This is just an engraving program that I did not that long ago. Let's see, it's in documents here in OneDrive. Let's see, CNC. Print G code, no CNC. CNC file, CNC G code. Real men run CNC machines engraving. There we go. Okay. So this is the program that I'm going to run. We're going to finish getting to where I need to zero it out. Where did I put that controller? I just had it. Oh. Okay, so I'll turn you over this way. I'm just gonna swing this screen around so I have my screen to start the spindle and all that. What is up with my touch? This is a new monitor. I had to replace it, and I don't think I set up the touch on it. It should actually be working on its own. It shouldn't need that. Let me try this. I hope I don't have to go in that one. It doesn't want to fit in that one with the HDMI. Shit. You're a fucking ball breaker. Let me just see. You know, I'll deal with this after. I don't want to do this with you guys watching on the video. I'll deal with it later. I'll use the mouse on here for now. All right, I'll turn it on to 1,000 RPM, and then I can change the jog speed this way until I fix that touch screen. Alright, let's slow this down. Actually, let's go to, oh shit. Honestly, this stepper with this driver, this closed loop stepper, it moves pretty damn good. I wonder what, if I had put all those, it probably would have been good too, but I love the servos being so quiet. And they're very precise, and they're very powerful too still, so Jesus, I'm so used to that being a touchscreen. All right. Alright, that's my 0 spot right there. Okay, so now I'm going to 0 out. I'm going to go to work tab, 0, 0, 0. I'm right in the corner, just barely touching. Alright, so stop. And I'm going to lift it up a little bit. Alright, and then we're going to start the program, and I'll let you guys watch it in grave. Let's see, let me get you in a position where you can see in there. Maybe I'll put you over here. Let's move my vortex. Alright, there we go. Alright, there you go, guys. Now we'll start it. Run the program. Where's my mouse? Where am I? There it is. Why don't I see what? Okay, start. No, I went a little too high. Hold on, let's stop it. I gotta bring it down a little bit. Alright, close that. This freaking screen. Okay, let's put the spindle on slowly, 1,000 RPM. I didn't go low enough. I didn't want to go too low, but then I went too high. Let's put the jog speed down to 1. And just bring it down a couple. Alright, I'm going to go right there. And I'm going to switch to the work tab and 0 out Z. Oh, I am in the work tab. Z is going to be 0 right there. Now I can stop it and rerun it. Alright. There we go. Now it should be good. There we go. See if I can get you guys in a little closer. Oh yeah, it's a little low. It's not exactly in the right spot, so it's the last row, the last words will be, or word, machines will be a little off the bottom. Oh no, actually it's just to the bottom. It's actually not off. So that'll work out good. I could have had this go a lot faster. I mean, honestly, it seems more like that with these servo motors than it did with the steppers. Right now, it seems like I could have gone tremendously faster. And with the steppers, it seemed, I knew it could go faster, but it didn't give you that feeling. Like looking at it now, it's going very slow for these. I'm definitely very pleased with these motors and definitely going to keep them. I'm not switching it back. This is the final setup for sure. Hi, Duke. Come here. Come up. Wanna come? Come up. Come. Come here. Duke, come. Duke, come. Come here. Come up. Come. Come up. Come up. Come up. Good boy. Good boy. Good boy, Duke. Come. You good boy. You're the good boy. Duke's the good boy. You're my good boy. Yeah, my good boy. You see the machine? Look. Look, you see it? Look. You see the machine? Look. Look, Dookie, you see? Come, look. You see? Good boy. You see the machine going? Talking to my dog, by the way. Good boy. All right, that's the last letter. It goes back down and does the I in machines last, and then it's done. Okay. So I'll bring you in and let you see that. Let's take the camera out and we'll go freehand and show you that. So there, that's what it just did. That's what I was just messing around. That's the first time I actually engraved with this machine. I think I mentioned before, I usually do it with my laser engraver, my fiber laser, and it does pretty good. It doesn't do that though. It's you know, that's really engraved. And the 60 degree, if you wanted it to be a finer point and not get so wide, the letters, you can make them wider or thinner in Fusion. Fusion has unlimited option, like practically unlimited options. It's a profound amount of things that you can change on there. But anyways, the upgrades to the CNC were a success, a very big success in my opinion. Everything was working fantastic. I had to get a new screen because my other one just gave out for some reason. I don't know why, but I have to get this touchscreen working on it. But other than that, the water cooling system, the flood cooling system. I haven't watertighted everything, so I don't want to have it running like crazy, but I will show it to you just for a second. Oh, I gotta shut this off. Okay. Yes, close. Oh, well, it ain't gonna have too much good at going out 1 inch per minute. See how quiet that is? How smooth? Oh, it's just unbelievable. So smooth. So I'll just turn the coolant on for a moment so you can see it, because that was a huge upgrade in my opinion. That's that thing that it was using before, the flexible piece that it comes with, not good. It moves all the time and it does not get the kind of flow that I get now. That's why I used all hard pipe. Aside from not having to have multiple mounting locations, it's all in that one location, which I have to tighten back up because I have to take that off. But you have that advantage of only having one location to mount it and it's stable. But even beyond that, when it's spraying and when it's machining while it's spraying, they don't move. They're fixed. I mean, you can move them manually, but it's not easy to move. It's not like they're pretty rigid. They're pretty stuck there. And as you can see, they're all right on. Like, I'm going to move this one down a little bit to go where the others are. So you have to move it by hand. It won't move on its own. It's too stiff for that. But there we go. They're all going right on the bit. It's not wasting water, wasting coolant, spraying it all over the place. They're all going. It's going to cool it tremendously compared to what it used to. That's going to make a huge difference. A huge difference. So yeah, I'm definitely pleased with that. That was a very worthwhile upgrade. If you guys want to consider doing this, it's 2 manifolds, 2 3-port manifolds. Well, they're actually 6-port, but there's 3 on the main face, and then there's 1 on the back and 1 on each side for if you want to keep going straight through, and then put 3 coming out, and then you could come in the back and then plug whatever you don't use. I just machined plugs out of aluminum and you know, put some Teflon thread tape, the thread sealant that I use. For water or liquid, I use PVC tape. It's like Teflon tape, but it's PVC tape. It's the Blue Monster stuff. and that just made the quarter NPT, National Pipe Thread, plugs, and plugged all the open holes, and just ran 1/4 inch pipe. And you know, I had all these fittings, so I didn't have to thread any of the fittings. But 1/4 inch fittings are not that easy to come by. They're mostly for pneumatic stuff now. They used to be more for gas lines and stuff like that, but people don't really use 1/4 inch for that anymore. If they do use 1/4 inch, they use flexible copper or soft copper that you can bend. But anyways, the machine's running fantastic. I can't wait to do some real parts on it. I'll probably add a clip of it machining some bigger parts so you guys can see it, you know, really in action. But at least I got to show you with the new servo motors how quiet it is and how well it's running with on the screen, first of all, while tuning it, and also you got to see while it's engraving. So hopefully that was informative, and you guys got to see the inside of the enclosure and what I changed in there and how I did it and all that kind of stuff. And the parts that I used that big 20 amp 48 volt power supply. That's powering everything. The control board is right off of a buck converter. The buck converter it's buck, B-U-C-K, if you don't know what I'm talking about. The buck converter has a pentanometer. You can turn it up and down so you can control the voltage coming out. It's got 36 volts coming out, which is exactly what that control board wants, because that's what it had before. And I spoke to Josh at Langmeyer, and he said that yes, it does want the full 36 volts. So I'm glad that I spoke to him. I'm going to let him know how I made out with the servos. He didn't really have any information on servos, didn't have a lot of experience with servos. So, you know, he'll have some experience from me telling him now. But hopefully it helps you guys all out too. If anybody is considering this, I've only seen literally one other video of somebody using these servos on a CNC machine. The only other videos, Cloud42 had all his videos with the lead screw stuff, which he did thorough testing with it, and those are really the best other videos out there. I did do testing with these motors, and I probably should have recorded some of it. Maybe if you guys want to see that, let me know, and I'll do the videos. The way I did it is I didn't use like a pulley and a string like he did. I used a pulley, a GT2 pulley, and a GT2 belt, and I put a weight on the end of the belt, and I fastened that to the belt, and then I was pulling the weight up with the motor. So the motor, I'm holding the other end of the bolt. The other end of the belt, and I'm just holding it so that it doesn't slip. You know, I'm not actually pulling it because the motor's holding it with the teeth. So it would be slipping teeth if I pulled it. I'm not pulling it at all. And I'm letting the weight rest on it. So, and then it's got to hold the weight and then also pull it. And I did it with 17 pounds. So that was the most. And the 17 pounds was no problem for either of them, the servos or the steppers. What did differ was the steppers, when it got up to the ledge where I had it in a straight NEMA 23 motor mount that was in the vise on the bench. And when I got to the bottom of the bench, and the stepper would hit it, and then it would break. It would give loose steps and drop it completely, and I would catch it. The servo would not drop it. It would keep fighting, like going back and forth, and it wouldn't give up. I didn't get that to give up with the weight. I did get it to give up manually, but they are very, very strong, and they're much, even though the torque rating is so much different. If you look at torque ratings on stepper motors, like that stepper motor I tested it against was rated for 3.2 Newton meters. This is rated for 0.6. The problem is that 3.2 is holding torque when it's off. Not when it's off, when it's on, but stationary. And that's because there's a permanent fixed magnet in it. That permanent fixed magnet is what also makes it move, but that's what gives it that torque, that holding torque. It's not, and once it loses its torque, it doesn't try to maintain it or go back. Not even the closed loop stepper will, but it's not the same. It's like trying to catch up steps, but it can't be as accurate, and the encoder's not as accurate. So there's multiple things. On the Z-axis, I don't see any problem having the stepper because first of all, it doesn't have nearly as much to do. The z-axis is only going down a small increment and then staying still. That's it. So it's only got a small movement, and you know, there's not very many big movements in the z-axis on a CNC machine, or frankly on a 3D printer, or you know, most machines, because Z is only going up and down at a slow pace. You know, however deep the next cut is, or however thick the next layer is, or whatever. But that's why I figured in Z it would be fine. And the weight of the tool head making the servo motor unhappy was not something I wanted to leave alone. So, but anyways, it does work great. It's you know, obviously I'm gonna make some parts better than just engraving in a piece of metal like that, but when I do, I'll add some video of at least one part being machined. But yeah, I'm very happy with it. I'm very happy I did these modifications. I could have done without doing it the wrong way first, but that tends to happen more frequently than I'd like. Because not that I did it wasn't wrong, it just wasn't the way I was going to stay with. Actually, those stepper motors that I put in were tremendously more powerful than the ones that were there. I don't know what the actual excuse me, what the actual torque specs are. I did ask Jake how much amperage they could take. He said 4 amps, no problem. Or I think he might have said more than 4 amps. But anyways, the ones I got were rated up to 6 amps, and they were 4.2 newton meters. And they're fairly small for 4.2 newton meters. Those were the 2 y-axis, and they were very powerful. But still, I tested them, and they outperformed the longer 3.2 newton meter, but they didn't outperform the servos. So, I mean, that's you can take that for what it's worth. But I'm happy to do those tests again if you guys do want to see those motors tested in a different fashion, the way that I did it. And you know, maybe I will get a torque tester. If you guys really want to see them tested, maybe I'll say screw it and order one. The torque tester that you hook the motor shaft to, and the motor shaft goes right to the shaft of this torque meter, and you can get a display, or you can get ones that actually have a little display on them, and it shows you how much torque it's putting out in newton meters. And you can get them up to 100 newton meters, you can get them up to 1 newton meter, you can get them all different ranges, and they're obviously different prices for the different ranges. This mill, I did end up putting a bigger driver on the stepper motor. I put one of those big 860s that I was using for the bigger steppers on the MR1. It's a stepperonline 860 DM860T. It's a digital driver, and for the x-axis it's working much better. I gave it quite a bit of amperage, so I think it's on like 4 amps or maybe a little more, because when I was making cuts, I was finding, you know, the other one was turning just fine. It was going left and right just fine, but it wasn't going just fine when I was cutting. So that I didn't like that. So I I put one of the better drivers in there, and gave it a little more power, and now it's blowing right through it. It doesn't stop for the deeper cuts. So it pushes right through. I forgot to, I uploaded one of the other videos of doing the modifications to this. I don't know if I got them all in there. I did do a full one-shot oil system, and I got a powered oil pump with 2 liters of oil it holds. If you can see it right next to the cutting oil back there, the rigid cutting oil bottle. Here, let me move the table, you'll see it. Right there, that's the 2 liters of whey oil, and it's pretty much full. And I've been using that. I got Gates whey oil, slide whey oil, and the manifold is right there on the side of the machine. I'll show you that close up too. So there's the pump and the oil, and you can see the manifold right there with all the hoses coming out, and the hoses go to every single. And it even has a pressure gauge on the pump that shows you how much pressure it's putting out. But they go to every single oiler. I drilled and tapped every oiler and put a push connect fitting on them, and they're all sealed with O-rings. And I had to use. I was hoping to get them all tapped M5, but a couple of them were not much larger than M5 in the brass, so I had to go bigger than the brass, which was like I had to go in M8. And because I had these reducers that take an M5 and on the outside they're an M8, they're double threaded, and then they have like a notch in them so you can turn them with a flathead, which I didn't use the flathead, but I just Teflon, PVC taped, is it PVC? It's anyways, whatever acronym, I'm losing my train of thought. I put the thread tape on the joint going between the fitting and the spacer, and then I tightened the fitting in like that with it already on there. So it worked really well. All the slideways are oiled nice and efficiently whenever I press the button, which I put it on a switch because it has a timer on it that automatically will oil it in intervals, and you can only go to, it's 3 digits, so you can go to 999, so 999 minutes apart, I think it's minutes, and then it will run for in seconds up to 999, how long you want it to pump for, which I don't want it to pump at any set schedule because I don't know how often I'm going to use it. If I'm not using it that much, I don't want it to pump at all. So that's why I don't leave that on. I put a switch on it. But every time you turn on the switch, it'll pump for as long as you have it set to. So I put it at 999 for the interval. The pump time is like 3 or 4 seconds, and that's enough to get all of the fittings. And then also the manifold has a different. They're all valved, so you can open certain ones more than others. It's like a gate valve, so you can open it a little tiny bit or more, and then based on how far it's going and if it's going upward for the Z-axis, obviously you want those open a little more. Certain ones you need open a little more, and then the ones that are very close and don't have to go up, you close a little more, so it oils it evenly. But the fact that you can do that is great. And then I got all the axes squared away with the DRO. So the DRO is working. There we go. It's Y, and there's X and Z. Oh, and also I mounted the motor on the top of the Z-axis, so now I have the crank still on the side, which was definitely an improvement. I'm glad I was able to do that. Not that I'm really going to use the handle, but I figured why not, The one from Priest Tools would have done it, and I told you guys about that, so I just I figured I may as well do that too. Since I'm not using it, I may as well make it at least that good. But yeah, I'm very happy with how everything turned out with this as well. And the lead screw project, I'm very happy with that. I got to tell you that guy, James, very, very talented guy, very, very smart guy. So it's very, very gracious of him to share his expertise and knowledge about this stuff with us, and make the boards for that lead screw project and sell them for an incredibly reasonable price. I have a whole nother set. I have a whole nother bud box with the whole thing all ready to go, the TI board and everything. So if any part of that fails, I'll just swap it out, because it honestly is like $60 for. It doesn't come with the bud box. That was another $6. I mean, the TI board is actually fairly expensive. It's like almost $100. I think it's a lot. In his video, it was like before COVID. He had done it, and it was like a $35 board, and now it's like $100, or $90 or something. So that goes to show you the inflation that hasn't gone down. But anyways, yeah, that's that. But I'm incredibly happy with that, and with all the other stuff I did to the lathe, the new DRO screen, the chuck, and then all the other stuff I've been doing in my machine shop. The being able to make my own keyways with the broaching kit, and my shop press that I modified over here. That is a standard run-of-the-mill Harbor Freight shop press. That is a 20-ton, and I took the jack out and I got a pneumatic powered jack, so I can just step on the foot pedal here that I got separately and pump it. I got the valve shut off from the reserve tank, but it goes very quickly when it's in there. So when I want to cut a keyway, it's very easy to do on this, and I can do them pretty much as big as I need to. I haven't had to do one very big yet, but the ones that I did do for the 14 millimeter and the 5/8, they were a piece of cake. You know, you go through 2 or 3 times, once with the broach, once with the spacer behind it, and then once with a bigger spacer, and that's it. It's in there. It's perfect. And it's the best. You can't cut that any other way, really. So anyways, I will wrap it up here. I hope that you guys enjoyed, and I appreciate you watching. And if you have any questions, don't hesitate to ask. I always respond to you guys. I'm sure you guys know that if you've ever put any comments in and asked me any questions, I always respond. I always answer you guys, and I'm happy to answer you guys. I mean, that's why I'm doing these videos, to try to benefit you, as you know, just like things that you guys have done have benefited me. So what goes around comes around, and I appreciate all you guys, and I hope that this is helpful for you. All right, have a great day, guys. Later.